Okay, let's talk conversions. If you've ever done conversions in like chemistry or something, this should look very familiar. We're going to start with this. We know that 2 pi radians is 360 degrees. 2 pi radians in a full circle, 360 degrees in a full circle. So we also know that pi radians is 180 degrees. Divide them each by 2. We are going to use that for our unit conversions. Here's how we do it. We're going to multiply each of these by a fraction. Now in this fraction, I'm going to have pi radians and 180 degrees. The only thing I need to decide is am I going to put the pi on top or on bottom? I get to choose. I am going to choose for this first one to put the pi on bottom, the 180 degrees on top. Now here's why I chose that. Because I want my pi's to cancel. And if I have a pi on top and a pi on bottom, then they cancel. So I'm left with 180 degrees divided by 2, which is 90 degrees. So pi halves radians is equivalent to 90 degrees. Let's do the next one. Same thing. I'm going to convert this, multiply by a fraction. I'm still going to put pi on bottom and 180 degrees on top. So then my pi's cancel, and I have 180 degrees divided by 4, which is 45 degrees. So pi fourths is 45 degrees. Next one, pi thirds. Put the pi on bottom still, 180 degrees on top, so your pi's cancel. You get 180 divided by 3, which is 60 degrees. So pi thirds is 60 degrees. And last one, multiply by the same thing. So the pi's cancel, so we get 180 degrees divided by 6, which is 30 degrees. So pi 6 is 30 degrees. Now, something about these last two, the way I remembered these is just like we had talked about before. Sine goes with cosecant, cosine goes with secant. So the c's and s's are switched. I kind of do the same thing here. The pi thirds goes with 60 degrees. The pi 6 goes with 30 degrees. They're flipped. Okay, let's try these ones. Convert from radians to degrees. I'm going to have you pause the video, try out A, and then we'll do B as a class. Okay, did you get 225 degrees? If so, awesome. If not, go back and check your work. Now let's go the other direction. I'm starting with degrees. I want to go to radians. So I'm still going to multiply, but this time I'm going to choose to put my pi in the numerator and my 180 degrees in the denominator. Because now my degrees are the ones that cancel. I have a degree on top and a degree on bottom. So I get 270 over 180 pi. I can simplify that. By the way, I have a really quick, here I'll show you, method to simplify any fraction on your graphing calculator, and I'll just show it to you really fast. If my calculator will load. Yeah. Sorry guys, should have gotten it up beforehand. Okay, so I have my fraction, 270 divided by 180. Enter. Gives it to me as a decimal, but I want it fraction in simplest terms. Now you probably already know this is 3/2. If it's a weirder decimal that you don't know what it is as a fraction, you can hit math, and then number 1, the arrow fraction, so enter number 1, and then enter, and it converts it into a fraction in simplest form. So that's a quick trick to convert anything to simplest form fraction. So this is going to be 3/2 pi or 3 pi halves. You'll see it both ways, and either is fine. Now I did have a student ask, can I just leave it as 1.5 pi? Yes, you absolutely can, but if you get a fraction that goes on forever and ever, like 0.33333, change it to 1/3 instead of 0.333 repeating. This one, same process, but it's negative. Make sure I'm doing this right. Yep. By the way, quick review. Do you remember what negative means? Negative just changes the direction. So if I'm going counterclockwise for my angle, that's positive. If I'm going clockwise for my angle, that's negative. So negative 120 degrees is just 120 degrees in the clockwise direction instead of counterclockwise. So let's convert this, doing the same thing. I'm going to put 180 degrees on bottom, pi on top, so my degrees go away. And I get negative 120 over 180 pi. Simplify this, 120 divided by 180. Math, change to a fraction, enter. 2/3. So this is going to be negative 2/3 pi, or negative 2 pi thirds. Okay, there you go. In the next video, we're going to be talking about angles in standard position and a few more reference angle stuff, but in radians instead of degrees this time.